Hi, welcome to the fourth module of LISP Your Mesh to Shape. I've called this module to ENTMAKE a mesh, and that's what we'll do, starting from scratch. Unlike 3D solids or surfaces in which DXF values are encrypted binary values, mesh objects are exposed in the classic AutoLISP fashion. Its values are regular numbers which can be easily manipulated through programming. This is a valuable asset for users interested in automating the creation of new shapes. The easiest way to understand how ENTMAKE works is by cloning an object from one drawing to another. I propose this exercise. First, draw a mesh in one drawing. We can do this by using the CMD mesh box function defined in the preceding module. To make it simple, use 1 for all the tessellation values. This will produce a mesh with 6 faces. Once the mesh has been created, we'll get its entity definition list with the NGET-ENTLAS expression shown. The list will appear in the Visual Lisp console or in the AutoCAD text window for Mac users. Then we can select the text. This can be done by clicking left of the initial parenthesis and copy it using the contextual menu or by Ctrl-C. After copying the text to the clipboard, we open a new editor window by clicking on the New File button or typing Ctrl-N. We can then paste the copied list in the new editor window using the contextual menu or by typing Ctrl-V. Once pasted, the list can be formatted as a column by clicking the Format Edit Window button. From this list, there are 3 items we must remove: the object's entity name in group code -1 and the group codes 330 and 5. These are exclusive for the original object. They can be removed by simply adding a semicolon before them. This is what is known as commenting. Commented lines will not be taken into account when executing the program. Commented lines are displayed as purple text with a gray background. We must then add the text parenthesis ENTMAKE apostrophe before the list and an additional parenthesis at the list's end. Once these changes are made, open a new drawing file. In the Visual Lisp toolbar, click the Load Active Edit Window button. This will force the ENTMAKE expression to be evaluated, creating an identical copy of the original mesh in the new drawing. This is the mechanism we'll be using in our code. But ENTMAKing any object requires a thorough understanding of the role each group code plays. This section will try to make this clear for meshes. The meaning of the DXF group codes can be found in the online documentation. But as not only the code, but the order in which they appear and the position within the list is meaningful, the way these codes are documented is very difficult to understand. I'll try to explain them using a real mesh entity list as reference. We'll use a tetrahedral mesh entity list, as this would be the simplest closed 3D object possible. This tetrahedron was created by the tetrahedron command included in the AU 2012 Mesh Lisp file. The initial codes are what I call the header. The header includes a series of group codes which are common to all entities. Of these codes, -1, 330, and 5 are unique for each entity, so they are not taken into account by ENTMAKE. Other codes, 67, 410, and 8, identify color, model or paper space, and the layer, and can be omitted as the system can assign the current values. Only group codes 0 and 100 are absolutely necessary. Code 71 is fixed, corresponding to the Shape Manager software version. Code 72 refers to the smoothing mechanism, although it seems to have no visible effect. Code 91 is the most important header code, as it will define the mesh smoothing level. The mesh header sequence is followed by the vertices sequence. This sequence begins with a group code 92 that indicates the number of vertices in the mesh, in this case 4. It is followed by as many group 10 codes as vertices indicated by code 92. Each group 10 sublist contains a vertex coordinates. The vertices sequence is followed by a sequence that defines the mesh faces. This sequence begins with group code 93. Its associated value is the number of items or sublists used in defining the faces. In the case shown, it indicates that the following 16 sublists refer to the object's faces. All of these sublists are identified with group code 90. Faces are defined from the indices of their vertices. The sublist following code 93 indicates the number of vertices for phase 1, in this case 3. So phase 1 will be defined by the 4 sublists following code 93. The vertex index refers to the order of group 10 codes in the previous sequence. Edges define both the shape of each face and the way faces are connected, as neighboring faces will share a common edge. The edges sequence is headed by a group 94 sublist that indicates the total number of edges. The sublists that follow, associated with group code 90, double that number, since each edge is defined by 2 successive sublists. For example, edge 1 is, in this case, the one that connects vertices 0 and 1. Each edge may have its own crease value. The crease sequence begins with a group code 95 equal to the number of edges. It is followed by that number of sublists with group codes 140 that contain the edge crease value. This number defines the highest smoothing level for which the crease is kept. If -1, it is always maintained, and with 0, never. Finally, if any subentity has been modified, it will be specified by a sequence that follows group codes 140. It begins with a group code 90 that indicates the number of subentities with modified properties. Understanding DXF codes is absolutely necessary, as the information that is passed to ENTMAKE should be structured according to the way the entity definition must represent it. Our next module will deal with defining a function that will create mesh objects using ENTMAKE.